Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 2 for this week, and going to be applying some statistical techniques to hurricanes and major hurricanes and tropical cyclones in general and see what we come up with. I have often talked about the fact that instead of assigning a normal high to a date, like a specific number, I think it would make more sense to talk about a normal range because there is year-to-year variability, as you all know. All December 15ths are not the same. And so wouldn't it make more sense to talk about what is a normal range as opposed to a specific number? I'm going to apply that same type of thinking to the hurricane season. And so that's what this bonus weather video is going to be about. So what I did was I went back and took a look at all of the tropical cyclone stats from 1991 to 2020, which happens to be the same 30-year period that is used for the normal temperatures and precipitation. Pretty difficult to discern a trend, a long-term trend anyways, with a period of time any shorter than that. So I just applied that same period of time, took a look at the number of named storms, the number of hurricanes, and the number of major hurricanes in each of those years. And of course, the 2 years that really stand out like a sore thumb are 2005 and 2020, when we had 28 and 30 named storms respectively, and we had to go to the Greek alphabet because we ran out of numbers or ran out of letters in our alphabet. So those 2 years will forever be remembered as incredibly active seasons. Okay, so just a few examples about statistics and how they are computed and what they mean. So on the left here, I've got a very simple set of data points at 2, 4, 6, 8, and 10. Well, the mean or the average is simply the sum of those numbers, and that's 30, and you divide by the number of numbers or number of data points, which is 5, and you get 6. So 6 is the average. The median is a little bit of a different animal because it is the number in that data set where there are the same number of numbers above it as below it, regardless of what those numbers are, okay? So in this case, the median is 6 because you have 2 data entries above it and 2 data entries below it. And so in this case, the mean and the median are the same. The standard deviation simply gives you an idea as to how much variance there is in the data, and in this case is 2.8. I'll talk more about that in just a little bit. Now over on the right, you have an even number of data points, and so you add up all those numbers, you get 42, you divide by the number of data points, 6, and you get 7 for the mean. The median, though, there's no middle number because in an even number of data points, you have 2 middle numbers. So those are 6 and 8. And so you add up 6 and 8, you get 14, divide by 2, and you get 7. And so again, in this case, the mean and the median are identical. Standard deviation is just a little higher because of the addition of that number 12. Now, I have often talked about, when I show the European ensemble mean precipitation forecast, that if the ensemble mean is higher than that gray box, which represents the 25th to the 75th percentile, or sort of the middle of the bell curve, that's a red flag. It means that there are a couple of outliers that are driving that mean upward. So here's an example of that. So we've still got our 2, 4, 6, and 8, but I replaced a 10 with a 40. So now when you add up those 5 numbers, you get 60, you divide by 5, and you get 12 for the average. The median is the same as it was the first time when we had 2, 4, 6, 8, and 10 because the middle number is still 6. And I would argue that the median in this case tells you more about the data set than the mean does because the mean is being distorted upward by that one outlier. Standard deviation is obviously much higher because the variance in the data is much higher. Over on the right, we have an even number of data points or data entries. And again, the middle 2 numbers are 6 and 8, okay? So that's still the same. 6 plus 8 is 14, divided by 2 is 7. And again, I think that is a much more reliable indicator in the data than the average because, again, the average is being distorted by that 40. So now a little bit about how to interpret all of this. So the mean or the average, plus or minus 1 standard deviation, will in most cases give you 68% of the data. In other words, 68% of the data points will lie within the range of the average plus or minus 1 standard deviation. Now, if you go to plus or minus 2 standard deviations, that should encompass about 95% of the data. And if you go to plus or minus 3, it's 99.7. So anything that lies outside of plus or minus 3 standard deviations is incredibly unusual, okay? So using that logic, if you will, here is how the hurricane stats that I showed you at the beginning of this video all break down. So the mean for the number of named storms over that period of time is 14, number of hurricanes 7, number of major hurricanes 3. The median is just one higher at 15, hurricane 7, major 3. So there don't appear to be any outliers that are distorting the mean in this case. That when the mean and the median are the same, that generally tells you that you have what is called a normal distribution of data. Now, the standard deviation is 5.4 for named tropical cyclones, 3.3 for hurricanes, and 2 for majors. So there's more variance in the number of named storms than there is in the number of major hurricanes. So if you apply the plus 3, plus 2, plus 1, minus 2, minus 3, what you get is plus 3 standard deviations for named storms is 31, okay? Well, what's the highest that we've had in that 30-year period? It's 30, okay? So it's pretty close to that. Plus 2 standard deviations is 25, plus 1 is 20. Again, the mean is at the top, 14, and then minus 1 is 9, minus 2 is 4, and minus 3 actually goes below 0, but you can't have negative 1 storm, so I just put a 0 there. So let's just say that we just went plus or minus 1 standard deviation. That would give us 9 to 20 would be a normal hurricane season. And you don't even have to go, 1 standard deviation. You could go like, a half of a standard deviation or 3/4. But again, I just think it makes more sense to look at a range than a specific number. For hurricanes themselves, plus or minus 1 goes from 4 to 10, okay? And on majors, plus or minus 1 goes from 1 to 5. So again, I'm just making the argument here. I don't think I'm going to change anybody's minds at the Hurricane Center about how they do this, or anybody else for that matter. It's just a personal opinion that a range to me makes more sense than a specific number because of the year-to-year variability that is very observable in just about all weather departments or categories. All right, that is it for now. That's bonus weather video number 3 for this, or number 2, I'm sorry, for this week. Number 3 will be coming up on Friday, and of course the next daily weather update coming up later today. So I hope you have a happy Wednesday, and we'll talk to you later on. Take care, everybody.